Thank you once again for joining. Good evening. Hope you're keeping well. I suppose someone has a follow-up question on the back of what we covered yesterday. For today, I have something a bit more interesting that hopefully will begin to get our hands a bit more dirty. So today we are going to look at the basics of compute, which is fundamental to every single thing we're going to do as far as DevOps is concerned. At the end of the day, when we do DevOps, all our work centers around manipulating a machine to fulfill an objective for us. So after all is said and done, say you're working on cloud, you're working on prem, you're doing all sort of stuff, it still all centers around machines. And from the way I look at things is the more of an understanding of the machine you have, the better it is for you as you kind of go along in your tech journey. Because AI, cloud, machine learning, web app, all these things center around running some services or some code on a machine. So I think it makes sense to start with how a machine is tamed in such a way that you are able to manipulate it and actually use it. So I think it makes sense to start with Linux basics, and I'm going to try to shed some light on what machine is, why we link Linux, and how things kind of move from your humble Linux to moving to the cloud. And after we explored Linux, machine Linux, and a bit of cloud, we are going to look at a day in a life of a developer. What does a developer do? And why would a developer need a DevOps person? But all these things will be from a practical standpoint. So there will be less of theory today, but more of like, seeing stuff and actually getting our hands dirty. As we kind of go through this program, I know we're going to be obviously uh, doing some exercises there and there. And I know some people we all have sort of different machines that we work with. Some people are running Mac machines, some are running Linux machine, some are running Windows machine. It's all fine. We're going to be able to support you, regardless of the machine you are working with. I think a vast majority of people here, I suspect, will be running on Windows. That is fine as well. But I try to encourage people that want to kind of go in the DevOps direction, even machine learning, AI, and all the rest of it, to, if possible, get a Mac machine. Because machines there is like a sweet spot between Linux and Windows. It's quite easy to use and it has all the capability and all the rest of it that you would need to fulfill your role as a top tech person. For me, Windows is not really the best, but it doesn't mean you cannot use it. But if I had to choose between Windows and Mac, it's going to be Mac all day. Of course, there's some learning curve you might have to sort of endure to kind of get acclimatized to using Mac. But as soon as you kind of get a hang of it, the rest is history. You would never want to use any machine else. But that is just by the way. We do support Windows, Linux, uh, or Mac. Thought I'd just put that out there. So for today, what I have is I want us to kind of take a step back and look at what constitutes a machine. Because the more of the understanding of the machine we have, the better we are able to kind of understand the DevOps journey better. So this class is more about computer and cloud basics. We're going to kind of strip everything bare. I'm going to do some diagrams. I'm going to do some explanation of, X and Y, and I'm going to show some little commands here and there. Most of what we're going to be doing on the cloud, as well as what we call the back end, will be all command line based, but you're going to see how easy it is. So don't fret, we got this covered. The only thing I'm going to say is whatever I do, obviously we are recording the sessions. You can repeat the steps, especially for people that are new. And over time, you get used to those steps. And obviously also try to stretch things a little bit Don't just stay on what we do in class. Try to get knowledge from other sources as well. So I want to start with let's go back. So computer and cloud basics. So a lot of noise around DevOps. As you would hear, as we said, DevOps is how you kind of integrate the developers and the operations guys and make them work, sort of synergize the relationship between them. So most of what a DevOps guy or a DevOps person would do will be centered around making toolings available and making platforms available. Yeah. And all this tooling and platform will center around using machines. In terms of the machine of choice when it comes to general DevOps is Linux. So I appreciate that on your own local laptop, you might be running Windows, whatever, Mac. But when it comes to backend, which is the enterprise where things actually happen, it's Linux that is quite ubiquitous, that is quite more common as a platform that is used in the enterprise. So it makes sense to understand and know a bit more about Linux. But Linux is, when we say Linux, Linux is just an operating system that runs on an hardware machine. What I mean. So let me show you something very, very brief. I just want to strip everything, but I want to make this a little not too I don't want to make it too just too much theory. So we will do a bit of theory and then we kind of get into action really rather quickly. But let's kind of establish some basics first, and then we'll build on top of that using practical exercises. So what I want to show here is some a bit of a diagram that kind of show us how a system is and how Linux kind of come into play, how systems interact, and how you will get on system to do whatever you want to do. While this is loading, just gonna wait for that to come back. Know why this is taking a bit of time to load. Sweet. Okay, we got it. So let's assume we have this is you here on your laptop. Let's say this is Taiwo laptop. Okay, Taiwo is the DevOps resource. Okay, this is Taiwo. It's a DevOps resource. He's got his laptop there. Okay. What typically happens is, not in all cases, but in most cases, Taiwo will be in his room. He would connect to the cloud, connect to the cloud, and then we'll be manipulating a machine somewhere far, maybe in Ireland, maybe in America, maybe in Nigeria, some machine. Okay. Now, it could be that Taiwo here might be running a Windows operating system on his laptop. Okay. And you agree with me that from a lot of, I think we are kind of all familiar with using a machine, right? On your Windows laptop, Taiwo might be running 7, 8, 9 apps all at the same time. But you might have his Microsoft Word running, maybe his Excel running, maybe PowerPoint running, maybe he's checking his email, maybe he's listening to music on YouTube. A lot of things are happening on Taiwo's machine. And while Taiwo is listening to music, he's also doing his work. Maybe he's connecting to a remote machine somewhere and manipulating some things on the machine as part of his work while listening to music and also doing some extra Excel things on his machine. So it would mean that on a machine, you could have several services running or apps, and they can all run concurrently, in the sense that the task you are doing, Excel task does not stop PowerPoint tasks from running, and it doesn't stop your YouTube from running, and it doesn't stop you, also stop you from doing what you have to do on your remote machine as part of your work. So typically on a machine, right, whether it's Windows or Linux, whatever, generally a machine will run what we call an operating system. An operating system is the software that sits on the hardware of a machine that makes the machine to be able to interact with us as human. At the end of the day, your computer is an electronic device. It has, transistors. It has electronic component and what have you. And if you want to turn the volume, let me give an example. If you want to turn the volume of your computer down, you don't have to look for the volume button, but you click on your software on your machine, and you kind of use the software to increase or reduce the volume. So as you are doing that, you're actually directly manipulating the hardware system or the underlying hardware that supports your machine. The system you're interacting with that's making that possible. That software system is the operating system, because it's the one that is interacting with the hardware on your behalf and making things possible. The way you interact with operating system would depend on how the engineers who made the operating system, the way they are kind of built it. And also, operating systems usually would have their target users. For example, the operating system you will have on your laptop might be different to the operating system that will run on a Linux machine that supports maybe give an example would be something like a voting app, maybe a voting system that will support maybe all the people that are voting in Nigeria or in the UK or in America. That operating system will be different because the target user of that platform will be different to you sort of using your Windows at home. The same way you have your phone, you have an operating system running on your phone that makes it easy to manipulate your phone. If also you have something like say you have a two-core Raspberry Pi, which is very smaller computers that allow you to open a gate, shut a gate, control your doors, etc. These are hardware systems that have operating system running on them to make it possible or easier to manipulate those hardware devices. A very good example is Alexa, which is Amazon Echo that you have at home that you talk to. That has an operating system running on that device as well that makes it possible to manipulate the device. So you will see that these days, most of the hardware system that we see around, they will need some software on it that makes it possible to manipulate the hardware. And that's what we call an operating system. And they all come in different shapes and sizes depending on what that machine is built for. Another example is your car. A car has an operating system running on it that makes it possible to play your music, to know about satellite navigation, to do some sensors. Maybe you are getting close to you're reversing and it beeps and all the rest of it, or even to track your car. So that operating system obviously is not the same as you running your laptop where you're able to increase, you click and increase volume, reduce volume. So depending on how the hardware is, the operating system behavior will be built tailored towards the hardware system. So in the case of Taiwo here, let's assume Taiwo is a DevOps guy. Say Taiwo is a DevOps person. Okay. Now Taiwo has a Windows machine. Maybe it needs to connect to let's call this a school portal backend. Let's say Taiwo Station is a DevOps guy that is been managing the school portal backend system. Let's also assume that the school portal backend system is a system that is used by students to as a portal system to obviously perform their school activities, such as, turning in assignments, downloading lectures, etc. So those ones too will have their own computers, maybe a mobile phone, maybe their laptops, and they probably will go to www.myschool.com. When they do that, let's say the web will forward them to the school portal, and they would obviously use the school portal as well. Okay, so we're going to establish some few things there, so that you will understand how the system works, and we can hopefully build on that. So the DevOps guy here, right? Whatever he's going to be doing, will be what we call the backend work. It will be things that would make these guys to be able to use the system sort of smoothly. It could be a case of maybe he would push updates. So maybe when maybe the website, maybe they are changing pictures on the website, maybe they're adding some new text to the website, maybe they are fixing some bugs on the website. Taiwo will be connecting, if you like, to the backend and making those changes. And these guys will typically be using the World Wide Web, www.myschool.com/whatever, and they will be manipulating using the platform via a browser. Okay, you will see that this is the same system, okay, that things are happening. So this guy is coming through the backend, and these guys are accessing the portal, the school portal, let's say, for lack of better term, through the front end. Taiwo would, as a DevOps guy, will interact with operations guys, will interact with developer guys to make sure that whatever new update that needs to be pushed get pushed to the backend so that these guys can see it. The way Taiwo would do that differs. One way of sort of connecting to the system is by, say here, one way Taiwo will connect to the system is by using sort of like a port connectivity. Okay. Likewise, these guys also will use port connectivity, which we're going to come to in a bit. What does that mean? So on this system here, for this platform to do its work, it will be running some services on it. Services could be something like email service. You could have web service. You could have file service, and so on and so forth. So on this single operating system, you could have several services working. So for example, email service will allow the student to have their emails on the system, and the web service will allow them to be able to use the school portal, and file service will allow them maybe to upload files, download files, etc. Okay. On a machine, because there are several things happening on a machine. The machine is almost like a big mansion. Okay. In a big mansion, you will have several rooms. In those rooms, they might be designed for different utilization. For example, in a mansion, you're going to have a kitchen, right? And you will not expect to find a bed in a kitchen, right? In the mansion, you will have a dining room. In there, obviously, you will not expect to find a toilet. And in the bedroom, and so on and so forth. The same things like for a machine. You have different services running on a single machine. Where you're going to go on the machine depends on who you are. For example, in that big machine, as using that as an analogy, if you are not a VIP, you probably will not find yourself in the master, for example, the master parlor or the master sitting room. Maybe you find yourself in a waiting area. And also, if you are not the owner of the house, you probably will not have access to the bedroom. Maybe you might have access to the dining room. Maybe you have access to the downstairs toilet. Maybe you might have access to the even to the kitchen, but you might not be able to get upstairs and do stuff. It's the same analogy when it comes to systems. So there are some guardrails and boundaries that are set on the system that only will allow certain people to use certain services. For example, the student here, they might be confined to only to use the web side of things as far as this machine is concerned. Even though this machine might be running 10 to 8 services on it, this student might be sort of be confined to maybe just using email and web service, or maybe even just web service alone. Okay. This machine, again, I want you to look at it as a big mansion. Okay. And when you go to a big mansion, where you find yourself would be determined by obviously how the owner has set the place up. For example, you come in now, let's say there are about 5 gates to get into the house, the big mansion. It could be that your invitation, based on your sort of caliber or your level, they might say Mr. X should come in through gate 1. Maybe that's not for the VIPs. Maybe the VIPs will come in through gate 5. So gate 1, gate 2, gate 3, gate 4, gate 5. It's access to the same mansion, but using different gates or different entry points, depending on your status. So gate 1 might be okay. Gate 1 is for general people to come in. Gate 2 maybe is for people that are more of higher caliber than gate 1, and so on and so forth. So the same thing happens on the system. So the way you kind of the same analogy, if you pass it to the mansion analogy, if you pass it on to using a system, would be something what we call, the gates will be likened to what we call ports, P-O-R-T, on systems. Ports are gates, P-O-R-T, that's a P-O-R-T-S. A port is a way through which you will gain entrance into a system to use a service. So if we're still using the mansion analogy, so if you're coming through a mansion and you're coming through gate 1, maybe through that gate alone, you'll only be able to access maybe the general living room, okay, because you came in through gate 1. Let's say if you had come into through gate 2, you probably would have been able to access the master bedroom. Let's say if you had come in through gate 3, maybe you have been able to access the ballroom. So the way chaos is managed on a single system so that it's able to do several things at the same time, it will be through port, especially for people that are coming from outside to use the service. So that is why, for example, if you, on this same machine, if you are coming from outside and you are a student, you would use www.myschool.com, just use an analogy. You would launch your browser and you say, I'm going to my school website. And you say blah, blah, blah. For example, let's even use Yahoo as an example, www.yahoo.com. Let's see, yahoo.com. Let's even use Yahoo Finance. Bear with me. Okay. Okay, so this is Yahoo, right? On this Yahoo system, as an example, Yahoo runs several things. Okay, where you find yourself will be determined by the access the Yahoo guys have given you, and the website, the URL you actually put here. Okay, so in this case here, the school guys would launch their browser, and they will put the URL of where they want to go. In this case, school portal. They hit it and they go there. Two things are happening there. When you put in a URL in the system, there's usually a prefix as you attach to the URL. This is very, very important. So this is HTTPS, Hypertext Transfer Protocol, secure. So this is saying I'm going to the system and I'm going to be going through gate something. This is what it means. So this is a machine, but this is specifying the gate through which it's going to come in. Because this machine is doing many things. This is just one of the gates that gives you access to a service on the machine. Okay. So because you are already specifying the gate and the machine you are going, the machine will then check if you are permitted to come in through that gate. If you're permitted to come in through that gate, yes, then you'll be able to see all those things. If you weren't permitted, then you probably will get let's say something like FTP, which is another gate to Yahoo. That won't work because you are not permitted to use that gate to come into the machine. Okay. You don't know this because all you generally would do is just say, I'm going to google.com. And then you say www.google.com and then you get into Google. But a lot of things is happening. You see that? That is telling the system you are going to Google machine, yeah. However, you are specifying the gate you want to come in through. Because if you don't come in through the right gate, the system will automatically stop you. All these things, you don't know that happens all behind the scenes. But the point I'm trying to make here is any service you use on a machine, if you're coming from external, there has to be a gate or port specified. Okay. And it is through that gate you will then be able to gain access to the machine. Let's still continue with this analogy. Taiwo, as a DevOps guy, will probably is not really interested in going to that same machine using www.school.com as a way to get entrance, because he's doing something more technical and more back-end. You probably will connect to the machine using a more privileged gate, as opposed to ordinary user who are sort of using a single service on a system. He might come into a specialized gate, maybe that if you like using the mansion analogy, maybe it will come into an underground gate that gives him access to everything in the house. It's just like you are the owner of the house, you probably will not use the same gate as everyone else uses. And because you're using a privileged gate, you then have access to everything in the house because you are coming in through a privileged entry point, as opposed to an ordinary user. So the point here is on a single machine, people have different access and different route to get into to use the machine. Another point I wanted to take away here is depending on the service you are interested in, that will determine the gate or the port through which you're going to come in. If you're interested in anything web, you probably will come into what we call the HTTP, HTTPS port. If you are interested in maybe file service, you will come in through what we call the FTP port. All this time you're gonna see it in practice. So I just want to kind of establish the basics first. So all this is sort of happening in the system, and the system that's sort of managing this, that's sort of coordinating and maintaining and sort of arranging all the activities to make sure they are working and working well is the operating system. So the operating system is the one that will manage, I need to make sure email service work, web service work, file service work. Somebody's trying to connect. It's like a butler of the house. If you kind of understand the English way of working, the butler kind of runs the house. The butler is the operating system who makes sure that everything in the house is running. So the butler could now be a Windows operating system, obviously managing the house, or some people might choose to use the Linux operating system managing the house. Linux has kind of proved its worth over time as the enterprise preferred operating system. It is not that they don't use Windows as an enterprise operating system. When I say enterprise, that it is more for robust sort of mission critical operations. So if you have a machine that is running, that sort of be running high critical services, usually people will use Windows as its butler, if you like, as the operating system. Sorry, Linux as its butler as operating system, because it's over time proved its one as stable, secure, etc. So that's not to say that Windows is not used. When it comes to enterprise, Linux by far is the most common. So it's the kind of, if you like, is the preferred butler when it comes to managing enterprise management. So with Linux, when you get onto Linux machine, usually at an enterprise level, you will be interacting with command line. You will see less of clicking, but more of putting command. But the thing you probably will achieve using, click operation, mouse operation is almost the same thing you achieve using command line. It's just like command line, you need to know the command that will be equivalent to you maybe double clicking, maybe doing a copy and paste. There will be an equivalent command for it. So it takes a bit of familiarization to understand that, okay, if I want to copy, there's no right click copy and then paste here. I'm going to have to use a command to do a copy and paste. Over time, as you practice, it just becomes second nature. So let's kind of see this in practice, okay? And I'm going to start with very at the basics. So because we want to play with a Linux machine, we don't have a Linux machine that we can play with, okay? So it makes sense to go to the cloud, AWS. So I will start from scratch here. I don't want to do this. Let me sign out, and then I'm just going to sign in. So you will see. So if you want to do this, you would go to just the AWS console, just type that, and then it will launch this, and then you can sign in. I hope everyone has already kind of set up his AWS account. We're going to look at Azure as well, but from next week. But let's start with AWS. I'm going to spin up a Linux machine, and I'm going to show us the basics, and then we'll go back to explaining cloud better. But let's just see a machine in action. So you click on to sign into console. All right, so this goes on. What I'm trying to do here is sort of connect to a cloud and spin up a Linux machine, which will be something like this. So this is me here. I'm still on my local machine here, or local laptop, which is what you're seeing here, but I'm connecting to the cloud platform. And I'm going to authenticate into a cloud platform because I want to create a Linux machine that we can play with. So if you are using your AWS for the first time, you probably will have a root account. Just sign in using root account. I hope you already created your account. And then I already have my username and password. I'm just going to say use my username and password, connect. Probably will send me a code, which I need to find. Okay, sometime it will put in a code which you need to go get and put it in there and so forth. When you land on AWS, this is what we call the AWS console, right? It's a vast ocean. This is the cloud. What you see might be different from what I see here, but it should be sort of similar, but it might not be exactly the same. One thing that might differ is what we call the region where you are. So in AWS, there are several regions you can position you can work. So here currently staying Stockholm region, which is Europe, from the London region. This is strange. Okay. So within the London region, there will be services that you'll be able to access, which we're going to come to. But the first thing you have to, I want you to take away here is the different regions here. And where you actually click will be where whatever thing you are creating, that is where it's going to be domiciled. I think there's some places in Africa. I think it probably might be, I think that we used to have South Africa. I can't see it here. There are a lot of regions, and I know enabling this account, okay, maybe because there's some limitation in my account. But we've got Europe, we got United States, you got Asia Pacific, and so forth. So you choose the region where you are comfortable. I would say just for duration of this program, so that we all kind of be singing from the same hymn sheet, let us use Ireland. So I want us to use Ireland so that what I see will be what you see. I know there are people based in America, there are people based in Canada here, but let's just use Ireland so that exactly what I see will be exactly what you see, because there are a little bit of differences here and there when it comes to services that's available in a region. So please bear that in mind. So what we want to do now is want to kind of create our first Linux machine and just play with it. Okay. So I would go here, just gonna go here, click on here. So what you have here is a list of services. So if you want to see all services, you can click and say, I want to see all services. And AWS will kind of group everything here for you in terms of services. Okay. In this case, because as I was saying yesterday, the cloud is a very, very mighty ocean. There's so many things on there. If you go from A to Z, it's quite a lot. There's no one single person that will know everything on a cloud. You have to choose your battle. It's almost like a hospital. You cannot, it's no way to know everything. So you have to major in something, and that's what you focus on. Right. So in this case, what we want to do is, because we are just spinning up a Linux operating system, we want to do compute. Okay, on that compute, we will choose what we call Elastic Compute 2, EC2. Select that, and then that will give us the interface to provision our first computer, compute, if you like, system. So this is what you see. In this region, Ireland, there are different data centers there, what you call availability zones. It's just like Ireland is a country, but Amazon has 3 data centers scattered around Ireland. So there might be one in maybe Dublin, maybe Dublin North, maybe Dublin South, maybe in another place in Ireland, but in different locations. These are physical data centers scattered within Dublin. Is to create redundancy so that maybe there's a fire in one data center, other data center can basically carry on, so your service doesn't die and you don't lose critical service because there's a problem in one data center. So within a region, you always have data centers. I'm not going to kind of go into this too much now, but we'll come to it as we kind of move along in the journey. So what we want to do is we want to spin up a machine. So to do that, we go to instances. We're just going to say launch instance. I'm going to be as economical as possible when it comes to details. I'm not going to say too much now. I'm just going to go with what is super important. So let's kind of create this and let's call it first Linux. First Linux. That's the name we're gonna call this machine. Can call it first Linux. And then we kind of Linux we want to create, the kind of operating system we want is Amazon Linux operating system. When it comes to operating system, there are different types of operating system. As I mentioned, there's Linux operating system, there's Mac operating system, there's Windows operating system. Even within the Linux family, there are different variants of Linux. It's like you are a Christian or Muslim, or you're Hindu. Within Christianity, you might be a Pentecostal, you might be a Catholic, maybe Muslim, you might be Ahmadiyya, you might be I don't know, different group within Islam as well, and maybe it goes for other religions. So within even a big family, you have different. Maybe within a clan, within a group, you have a different clan. Within a tribe, maybe you have different families as well. So within the Linux family, you then have Red Hat, you then have SUSE Linux, you have Debian Linux. These are all Linux, but different variants. We'll come to that later. But for now, for simplicity, we're going to choose Amazon Linux. So that's the operating system we prefer to use. So what should be our the kind of machine that we want to be? Remember, this is the butler that's going to control the house. But how robust is the house? Is it going to be like 3-bedroom mansion? It's going to be a 2-bedroom mansion? Is it going to be a humble bungalow? This is what this is speaking to. Like you can see, you can kind of select how powerful you want your system to be. You can go as far as doing selecting a machine for deep learning, or you can select a very humble basic system. So this is sorry, by the way, this would be the configuration of how the operating system will behave. This is not actually the power of the system. This is how the operating system will behave in terms of how the butler will manage the platform. When it comes to how powerful it's going to be, it will be the instant type. So how strong should this machine be? Okay. In your case, because we are kind of restricting ourselves to the free tier version, so there will be some that will be eligible for free tier. I think the T29 Nano, T2 Micro will be eligible for free tier. All the bigger ones, which are more powerful machines, might not be able to get those for free. But I think the T2 Micro definitely should be available for you to use for free. So be careful when you are selecting the strength of the machine. So some are not free tier eligible and you might get charged. So, but if you stick to T2 Micro, that should be free tier eligible. Should be able to use that for free. So that then determines how strong your machine is going to be. It's like, okay, I just want a bungalow. I don't want a duplex. Okay, I've got a butler. I need a house. Okay, now selecting the house, you want to select how access the house. How do you get entrance to the house, entry to the house? So this is what the key is about. So you can then create a key of how you're gonna kind of get entrance to that for that. If you don't, obviously for the first time you won't have a key, you can just say create a new key. I will call my key, I'll call it Masterclass 2025. I want to call my key. I won't go too much into this. For now, just go with the default, just put a name and just say create key. When you do that, it will create the key and it will automatically also download it for you on your laptop without you knowing about it. So that key would have been created here as obviously ready to use, but the actual key, which is file, would have automatically downloaded to your computer. You cannot lose that key. Let me show you in my case. If I go to, where is it? Let me see. If I go to downloads, show you here. That's the key. You can see it. It just came in my download. So in your own download folder as well, the key will be there when you create that key. You should keep that key and guard it jealously. Okay, so I'm not gonna touch anything here too much. There's a lot going on here. We're gonna come to this maybe week 3, week 4, but I'm just gonna kind of gloss over this for now, just to simplify. Make sure you stick to T2 Micro here. Make sure you have a key created. Make sure you choose Amazon Linux and don't change this too much. If you are in Ireland region, you will have Amazon Linux kernel 2023. If you go somewhere else, you might see something different. Okay, and we are specifying it with that. We only want one machine created. We don't building 2 houses. We just building 1 house. And then you would, I'm not touching anything else, and then you will launch. So this word is doing a lot of things that, around security, around access, etc. So when it's sort of provisioned, it's going to give you a link to it to be able to see it. So you click on that, and then you would see, it will tell you that this is the machine I have created for you, and it will give you all the breakdown of the machine. So under Elastic Compute 2, which is how you would create a machine, we have instances, and this is one of them. So if you want to see all the instances, you can click on this. It will give you a summary of the instances that you have. You can see we only created 1 machine. If you want to see the details of it, you can click on that. It gives you all the detail. You can go back, you can look at the summary a bit. And what is important here is status check. It's telling you if the machine is ready, but it's not ready now. It's initializing, it's being built. So you can refresh and see if it doesn't take too much time. It's still initializing. At the point it should be ready. So it's checking, but the instance is ready as well. It's just saying, I want to make sure that this machine is working well, but the machine is already running. Okay. So if we go back to our diagram, that's the little machine here that we have created in the cloud. But we don't have access to it. Yeah, we're not connected to it in any way, shape, or form. It's just created. Okay. So I can connect to the machine now by clicking on connect. However, before I connect, AWS, which is the cloud platform, will tell you how you can connect to the machine, because I want to connect, but it's telling me I have options. One option is to connect directly from here, the browser, and it will give me access. I can also use what we call a session manager, I can use SSH client, and I can use EC2 serial console. Okay, what I generally would prefer is, this is the easiest option, which is just to connect from here. Let's look at that. We're not changing anything. I'll just go back again, and I say I want to connect, right? And I'll say connect. And then it's trying to establish connection, and on it goes, on it goes, on it goes. Hopefully this comes through. Right, okay. We are now on the Linux operating system. Okay, you can see here this Amazon Linux 2003, blah, 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 and we're there. And then you can begin to play. I'm just hitting the enter key here, just to make sure the system is responsive. I can just, because I'm hitting the enter key and it's coming and responding, I know the system is responsive. Okay, on the operating system, when you land, you land in what we call if you like, from what we call a folder in Windows, or what we call directory in Linux. So it's like when you land, you're gonna land somewhere in the machine, right? When you land, where you land is your home directory, is your home. Okay, so on Windows, you will say, okay, what folder are you when you get on the system? So on Linux, there's a home directory where you land, when you connect, and you can figure out where you land by saying, what's my present working directory? Where am I? And the system will tell you, yo, this is the location you are. You're on the system, or you're in this folder. You're in home EC2 user folder. Okay. And going back to that analogy, that is me here, obviously connected to the internet, and now I'm on here and I'm playing with the system. Okay, currently we don't have anything installed on the operating system. It's still blank, it's still new. But I'm just putting some command there, such as BWD, where am I? And the system is responding to me and telling me that I am in home user. Okay, so the first task you might get from your manager, maybe as a DevOps person, maybe you're a newbie, it might be, Taiwo, can you please create two Linux machine for me. Make sure you're able to connect to it directly via the web link, also using the key that you generate when you were creating the machine. So it might be something as simple as that. That you've been asked to spin up a machine, and basically maybe one machine, maybe two machines. You can see how easy it is, and just make sure you spin up the machine. The task could be spin us two machines for me, and make sure the key that you generate is called key X, and keep the key for me. That might be a DevOps task for you to fulfill. Okay, so let's say we're on the machine. A machine is created for us now. We are in the currently in home directory, home EC2 user. When you create the machine, you might want to obtain some basic information about this machine. For example, you might want to say, okay, how much memory does this machine have? How much CPU does this machine have? And how much memory, CPU, and how much disk space does this machine have? Okay, what am I talking about? So when you have a machine, okay, the machine needs memory to store stuff. This is how the machine will process things. So when the machine is crunching a task, it has to put those tasks in memory. The bigger the memory, the faster the machine. Okay, the machine, what we call a CPU, central processing unit, which is the main brain of the machine. So the brain needs a table to operate. The table it will use to operate is the memory, but what actually operates on that table is the CPU. So this is hardware level terms we are using here. The memory is the table where things happen. The CPU is the engine that manipulates operation that actually perform those tasks on the machine, but it needs a memory to operate. But when things are done and processed, you need to store them somewhere, and they will store them in disk space. The difference between disk and memory is that memory is ephemeral, meaning that things don't persist permanently in memory, but you can process things in on the disk. So let's say, for example, the system wants to calculate what is 2 times 5. Computer doesn't 2 times 5. It needs to use an algorithm to work it out. but it would have to put it in memory to be able to do the calculation. You might say, do 2 times 5 for me and keep the result permanently. So the CPU would take the task, go to memory, work out 2 times 5, and then we then store the result on the disk. So that if the machine is powered down and you bring it up tomorrow, even though everything in the memory is wiped out, but you still have your answer on disk. So disk is what's it called? You can persistently keep things in disk. Memory is not that. Memory is ephemeral. So if you power down the machine or you need to do other tasks and there's no space, system might kick something out of memory and put some things back. So whatever you keep in memory, you cannot rely on it that it's going to be there forever. So you have to pass things. If you want to keep things permanently, it has to be kept in disk. But you need memory to actually allow the computer to do its work. What will determine how strong or powerful a computer is will come down to CPU, memory, also things around network, and also disk could play a role, and the kind of disk, underlying disk, also will play a role. But the two things that play the major role as far as speed or how strong a system is comes down to CPU and memory. So how would you know how much CPU a Linux machine have, how much memory a Linux machine have, how much disk space it has? So to do that, you go back. Let's go back there. It's the machine. So to want to do CPU, just say ls CPU, and I will give you, I want to list the CPU on the system. So it's going to tell you what it is. What you're after is how many CPUs do I have? Okay, that is telling you the CPU you have. What kind of CPU it is? It's an Intel Celeron CPU. Okay, the CPU family, etc. But when it comes to it, what is important as far as CPU is concerned is the core as well as the number. So some system will have a lot of CPUs that will allow them to do many things simultaneously. With one CPU now, this machine will be very limited in terms of what you can do concurrently. So this machine is not a top tier machine because it only has one CPU. So it can only do one thing at a time if you like, because he also has one core. So what will happen is what we call context switch. So for the system to kind of be able to do multiple things at the same time, it will have to leave one and do the other, leave one and do the other. So it will kind of switch from task to task because it only has one CPU. Okay, I don't want to kind of go into too much detail of this. There are a lot of things here, but let's just kind of stay on the peripheral for now. So LSCPU will give you what the CPU is, and if they ask you what are those key things that you want to look out for, I don't know how many CPU that are running on this machine. It's just one CPU. I would want to know how many cores the CPU is running. It's just one core. And that's what you need to know as far as the CPU is concerned. Obviously, if you want to know what kind of CPU it is, because your guy could be AMD CPU, it could be ARM CPU, it could be what's it called? It could be NVIDIA CUDA CPU, it could be Intel CPU, depending on so this is Intel CPU, Intel Xeon CPU. By the way, CPU is Central Processing Unit, which is actually the brain of the computer. So if you want to know how much memory, so going back to the same analogy again. So you want to know how much memory the computer has, you can say 3 minus m. I'm gonna tell you what this means in a bit. Okay, so it's saying the total memory on the system in megabytes is 949. What is used is 114, and this is what is free. So typically, this is almost a 1 gig because it's almost 1,000, a 1 gig system, and you have 100 megabytes being used and about 600 being free. If you don't want to do it in megabyte, you could do it in gigabyte and say 3 minus G instead of M. And that will give you the answer in gigabyte. What is it? Minus G. Pardon me. G. Because not up to 1 G. Maybe that's why it's approximating it to 0. It could have been in kilobyte as well, I suppose. So because it's not up to 1 GB, that's why it's approximating to 0, which doesn't make sense. So if you have a bigger memory system, you'll be able to break it down for you in gigabyte, because we don't have it up to 1 GB technically. That's why it's just summarizing everything as 0. But you could, normally you'll be able to do it in kilobyte, to megabyte, you should be able to do it in gigabyte. So usually M will always work in megabytes. And then say that is 419 meg, and this is obviously the memory we're talking about. Okay. In terms of disk, so in terms of disk, can just do what we call df minus h. So what this is saying is I want to do disk find. And so what this is saying, okay, on this machine, you have different mount points on this machine. So what that means is the machine is being the disk, which is where things are permanently stored, is being chopped into partitions. So you have what we call the dev partition. It's another partition. It's just like different sort of, if you like, pockets on that big disk. It's like you have like a big cardboard, and you kind of chop it into sections so that you want to keep maybe some things in A, some things in B. So by default, this is all done for us when we spin up the system. We haven't done anything. This is what we've just inherited. So, but what is important is in terms of what is used, what is available, because you can see now the biggest disk space here is what we call the slash. If in real time they call it root, because it's like a tree. This is the beginning of a tree. If you like, for example, this is the parent and this is the root, and then you have a subdirectory called run, a subdirectory called dev, and in dev you then have a subdirectory called dev shum. You can see it continue to build up, but everything starts from the source, which is the root. So the root itself has about 6.4 gig of space and only about 1.6 is used. So it's very, very important. People. So I see a lot of seasoned DevOps people, they don't know the difference between memory and disk. So when disk is full, they say memory is full. When the memory is full, they say disk is full. Okay, memory, you would never have memory as big as disk. It's not common. It's potentially possible, but disk is cheaper and more available. Memory is more expensive and less available. Okay, system, the disk, it might determine, it might have influence of how on the speed at which a computer will do a task. But what actually influences the speed of a machine is the CPU and memory, not disk. The thing you probably will run out of quickly, it will be memory and CPU. So sometimes when you give the machine too much task to do, it could die because the CPU is not able to manage the task and the system just get overwhelmed and then it will just hang and you have to salvage it by powering it down and powering it up, because it's like you are asking a primary five, primary four kid to do calculus. It's just gonna panic and it won't be able to do it. So the same thing goes for machine. If it's not strong enough, it would just hang and will not be able to respond. That's why maybe you on your laptop, you are opening too many things, you are trying to do too many, and you see that the system begins to become slow. It's because one, the CPU is being hammered. Also, the memory, where it's kind of putting all the things it needs to do, that table is getting filled up and there's no space. What it's then trying to do is trying to clear some things out of memory so they can bring something else in because it needs to work on those things. Because you're asking it to do something else, then whatever it brings to memory, it needs to play it out again because memory is not big enough. And then it will to bring it again. And then you see that system is just stalling before it then maybe eventually just dies. So memory is where the system will process active operations, and disk is where it's going to persist the results. So when you, for example, let's use Microsoft Word, for example, when you launch Microsoft Word, for Microsoft Word itself to run, you must have installed it. That installation file is on the disk. Okay, installation file of Microsoft Word is on the disk. As soon as you hit Word open start, some of those files will be copied into memory so that the Microsoft Word begins to play out on your machine. For that to happen, some of those files will have to be loaded into memory. Okay. You might then say, I want to open file 1, file 2, file. The more files you open, the more you are kind of saturating your memory, and so forth. Okay. So if you open 5 files, you probably will have 5 entries in memory, and the more you open, the more the memory gets filled up. And because you are sort of operating, working with Microsoft Word on your system, using the analogy, the CPU is not really hammered. The reason being that the task you do on Microsoft Word is not really CPU crunching, because all you do is you are typing, you are saving, and so forth. That would be different to maybe something like you are creating a video, maybe using something like Adobe Express, or using something like a video animation creator, which is trying to manipulate video, audio content in different frames. That would hammer a machine. And that will be more of CPU and memory utilization. And just if you are using the humble Microsoft Word, which would just be a high memory utilization, depending on how many files you open. So all these things make sense for you to understand as the basics. So that when you are talking, you are not mixing memory with CPU and you're not mixing CPU with disk. On the system, these are very important things: CPU, memory, and disk. One thing I haven't mentioned deliberately, I'm just going to highlight it very, very quickly, is it's a network interface. So let's say you have a computer, you have another computer, they need to talk. Obviously, there has to be some sort of a link between them. Because these days, computers don't exist in isolation anymore. They all talk, okay? So, and for computers to talk, you have to have what we call an interface card, NIC, or we call it network interface card on the system. Okay. So network interface card is where is the hardware systems that allow our computers to talk. So this computer will have a name and it will have an IP address, which is a unique identifier through which they can talk. So this will have a number, this will have another number, and through that they're able to kind of connect to themselves. Most systems in the enterprise will have a network, will have NIC. Otherwise, they won't be able to communicate. Your laptop has an NIC. That's why your laptop is able to connect to us and sort of engage in what we are doing today. So NIC is quite important. And when it comes to enterprise, the speed of the network interface card in terms of how the system are able to communicate also would determine how things get processed here. For example, imagine you're having some files stored on another system, and this machine needs to access those files and then process them. If the machine is fast, memory is good, CPU is good, disk is good. But let's say the network interface card is a bit wobbly, is not able to quickly connect to another system, extract the file you need and bring it back. Even though this is quick, if this is slow, the experience here will be generally slow. It's like you have a very, maybe a relay where you have leg 1, leg 2 very quick, but leg 3 is very slow. That relay will end up in jeopardy because one of the legs is slow. So for a system, a couple of systems to work well and work fast, you do not only need high memory and strong iCPU, you're going to need a very fast memory interface card as well to make sure that things work and work quickly. So if we go back here, we'll say, okay, bear with me. So we want to check what things look like in terms of IP address. You can say IPA. So this is IP address all, and this is telling you this is what the system looks like. So look back. This is very not important. This is how the system is able to talk to it internally. Don't worry about this too much. The ENX0, this is this. Obviously, we don't have a second system. But we coming from outside, the only way we're able to connect today is because this system has a network interface card. And that is how we get in. So the ENC one is the network interface that allows connectivity to the machine. Without a network interface, nobody will be able to connect to this machine. So because we are coming from outside, we are coming through this ENX0. And the local IP address of the machine is this. What that means is if you are within the local sort of network area of the machine, you can use this local IP address. Usually, machine will have what we call the local IP address and public IP address. Public IP address is the address you have to use if you are coming from the over the internet, as we are coming over the internet. If you want to access this machine, we cannot call it its local name. We have to call it its public. It's like you live in the house, maybe in that house, people that are close to you, they know your nickname. Maybe the real name you bear outside is actually not the name they call you at home. But people that are close to you, they know what your nickname is. But people from outside, they don't know your name. So we coming from outside, we have to use the public name that you bear. Or people that within your circles internally can use your nickname, in this case, local IP address. If you're coming from outside, you're gonna have to use the public IP address, but that is what is publicly known. So if we go back to the system that we provision, which is this same system, if we kind of look at the summary of it, if you come here, you will see networking. We see as a private IP address, which is 172.31.42.113, which is what we see here. 142.113, that's the local IP address. But it will have a public IP address as well, which is that one. If you wanted to connect to it, we will have to use that, and I'm going to show us that in a bit. Also, the system has an IP address, which is obviously numbers. Also, it has a name. You can connect it. If you don't know the number, you can use the name. There's a public name. There's a private name. So this is, there are a lot of things going on here, which I don't want to talk about now. Availability zone, security, storage, so forth. We're going to come to that at some point later, but it's important to just keep to the basics. If you can know where you are, where am I? If you can also say how much CPU you have, LS CPU. If you can also demonstrate that you can do free minus M to look at memory. And then you can also look at this by using df minus h. That should do nicely. And if you can just top that up and say IP minus A to look at the IP address information, etc. That's a great start, because this is the foundation that everything gets built on. Of course, you can then say, okay, I'm in this directory, okay, or what is in that directory? So I'm in this folder, but what is in that folder? The folder I am. You can then list that folder for me, and then you can see there's nothing in the folder. Okay, list, there's nothing there. So currently in this folder where we are, because it's a new system, there's really nothing in the folder. Okay, and then finally you can say, okay, I've played with a lot of commands today, right? I've done ls, I've done pwd, I've done free minus m, I've done lscpu, I've done df minus h, and so forth. I can do a history of what I've done today. Give me a history of what I've done today. The system will tell you this is what you've done today. You've done CPU, you've done free, everything. As well as a nice little way of capturing all the things you've done and then keep it in somewhere. Typically, when I work, I share my history with my students so they can have a history of my command and then use that as their sort of reference point. Okay. So if we just circle back a little bit, we've said a lot of things. We've not really engaged these guys. We've not done anything that regard. What we've done is we've just basically looked at how to spin up a system on the cloud and connect to it. In terms of connecting to that system, obviously we created the EC2 instance in region, island region, okay, and we created one single instance. And then we did then try to obviously connect to it by selecting the instance for Linux. And then we say connect, and then we connected to it. And before I connected, I did say to you that there are more than one way to connect. Session manager will be one way, SSH client, EC2 serial, blah 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 is another way. So, but the one we chose, which is the easiest option, is to just go with the EC2 instance connector, which we did. In reality, is usually people don't use this because it would mean that for you to connect, you always have to come onto this platform. AWS, you have to log on and then find the system and connect. People typically don't connect using this way. They will want to connect directly from their machine without having to come into AWS. So for example, let's say I end today's task, I go home, right? So let's say I'm done for the day, I then go home, see, I then log out, sign out. Obviously the machine is not dead. So the machine is still running. I don't have access to it. So let's say I want to access the machine tomorrow. It will mean that I will have to come to AWS. I will have to sign into the console. It just takes time and it's just slow things down, as you can see here. It comes back. Don't know why things are a bit slow today. Right, it will eventually come through. Sign again. Sign again. It's come through. It just takes ages. So because I want to access the machine, I'm having to connect to the platform. Just say connect as root. And I'm going to use the master class connectivity details. Going to select that. And then I'm in. And then I will go here. And then I will go to running instances. View dashboard. And go to running instances. And I can see my running system. Yeah, I can select it. And I will say connect. And I will connect. Okay, so this is one way of connecting. I will not explore the other ways in this class because I want to simplify things as much as possible. So, but this should do nicely for the first few weeks when you start this class, right? For people that are new to it. So, but for people that are kind of, been in this game, please, I see this people mixing memory and disk a lot. Hopefully I've cleared that a little bit today. So now you have a system. So what then? So you have a system, you have Linux, blah, blah, blah. So what then? So you are in PWD, so in directory you are. One thing you can do is you can create a folder. So, okay, I'm a DevOps guy, I'm on this Linux machine, I want to create my own little space where I do stuff. So I can make a directory, I say make directory, create a folder. I'm going to call it master class. Master class. If I can spell. Okay, I've made a directory called master class. So that directory will obviously exist in this current directory. So when I say directory in Windows Word, you call it folder, but try and kind of lose that term if possible. Just use directory instead of folder. Those are the kind of thing that gives one away as being a newbie. So just say directory instead of folder, directory. Okay. So in this present working directory, which is where I am, which is my home directory, I have now created another directory called master class. If I say list, now I should have one single entry called master class. Remember when I listed earlier, there was nothing. So, but I have a directory called master class now. How do you create a directory? Just say make directory. It's like creating a folder. Make directory master class. Okay. There's a difference between a directory and a file. Okay. If I wanted to create a file, I will say touch. first file. I've created a file and I've created a directory. So if I say list, I have a file and I have a directory. But how do I know this is a file? How do I know this is a directory? Because I created them, I know. But what if you didn't create them? Let's say this was clear. Let's say there was nothing. We don't have like a reference. I clear all the command, everything is clear. If I then say ls, how do I know that this is the file, this is the directory? The way to know that is you can't really know. You have to put some extra flag to go with the ls so that it would tell you what is the file, what is the directory. I will say ls minus LTR. So list and do me a listing, base it on time and do a reverse order. So that is what of the ls minus LTR. You can do it just ls minus L, just do list and it will list for you. Or you can also do ls and order the thing based on timestamp and do it in reverse order. All this will come natural to you later. But let's do that ls minus L for now. And let's pay attention to this. This first to, bear with me, this thing. The very first thing you see here is a dash and a D. When you see a dash, that means it's a file. When you see a D, it means a directory, which is a folder. And that's how you know. All this we're going to talk about later, the RW dash RR dash R dash. This one have a very important meanings, but I'm not going to dwell on them right now. But just say, how do you distribute between a file and a directory? You do ls minus L. The first character will tell you if it's a file, if it's a directory or not. If it's a D, then it's a directory and called a folder. If not, it's just a file. Because it's a folder, you can go inside the folder. You can just say go inside, which is change directory, CD, masterclass. And then when you are typing in Linux, you don't have to complete the typing. You don't have to type everything. You can always do a tab key. Just type a little and just say tab. And then we'll finish it for you. And then you say CD tab, and then you're in the directory. If you then say, where am I now? Where am I? Where's my parent working directory? You can see it's changed. You were initially in home user, but now you're in home user masterclass. So that's level 1, level 2, level 3. Everything starts from root. In root, there's home. In home, there's system user. This is there's masterclass. Okay, I'm very careful. I don't want to inundate you in the first week, but I want us to establish some few things you can play with during the week. So we've created a directory called masterclass, which is a subdirectory of EC2 user, and obviously a subdirectory of home. So home is where things start. In home, there's a guy called EC2 user who then has a subdirectory called masterclass. And then PWD again, that's where we are. How did we get to masterclass? We changed to masterclass. CD, change directory to masterclass. Okay, we can go back. There's nothing to in masterclass, there's nothing now, right? We can take a step back and say we want to get out of masterclass. It's still another change directory, but just back up, just go back. Go back means ... Okay, it means go back. So you're back in PWD, back to where you were before. Just again go to masterclass, new masterclass, and then you can say in masterclass I want to create a directory called week 1. You notice the way I do my typing, I'm not putting space because space is a problem in Linux. And I'm waiting for now. I want you to do your typing with no space when you are creating. So when you're giving a name to something, don't say week 1. Just say week 1. Okay, we're gonna talk about why that is later. But everything should kind of be put together just for now. I will create the record week 1. Okay, if you list what is in there now, you only have week 1. You can do list minus L to actually make sure it's a directory. You can see that as a directory. And then in week 1, we can then CD to week 1. We can change to week 1. And then we can say, where are we? You can see we are in home user masterclass week 1. And then we can back up one step. And we're back in masterclass. We can back up one more step. You're back in PWD. You can go again, masterclass. change directory space is the command. Where are we going? Masterclass. I can actually go straight into week 1 as well. And then you can see, where am I? You're in week 1. And I can back up in one go, one step, and another step. And then you will back to home, which is there. So you can see the directory structure here. Home, EC2 user, masterclass week 1, which is what we've created. But this, what we're doing here, we have not done any installation. We are just playing with what is out of the box, which comes natural, which comes sort of not natural, which comes out of the box with the Linux operating system. So you can create a directory, you can view your directory, you can list your directory, etc. There's a tool called Tree. That tree allows you to see your directory better, almost like a tree structure. So what I'm going to do is I'm going to create a few directories, and I'm going to use Tree, so that tree will actually make us appreciate this directory structure better. So in here, we see that we've created a file, a directory called masterclass. In that masterclass, we have week 1. We can create another directory also in here. Let's call it school. Let's create another directory, make directory. Let's call it football. So in this directory now, we have a number of directories, masterclass, school, football, etc. Right? So if you wanted to kind of show, and then we actually go back one step, actually one more step again, cd dot. We are now here. You can see now we are in home, pwd, we are in home. We can jump back to EC2 user, etc. So let me clear the screen. We are kind of using space, ls-lt or ls-l. EC2 user, we can go back to EC2 user and then ls-l, see that. So there's a tool called Tree that allows you to see things better. So I'm deliberately talking about Tree because I want you to see that one other thing you can do on the Linux platform is you can install an application. So we've not installed anything so far. We've only been playing with folder creation, file creation, listing of folder, checking CPU and stuff. But sometimes you might need to install an app. The way you install Microsoft Word or Excel or PowerPoint on your Windows machine, you can install tools on the Linux platform as well. So the application that manages installation on Linux it differs from platform to platform. So there's always one application manager that allows you to do an installation. For example, on Windows, there's something called Control Panel. Control Panel allows you to manage installations of app, install, uninstall, etc. The Control Panel of Linux it has different name depending on the type of Linux you find yourself. On this Linux, there's a tool called YUM, YUM, which you're going to be using, which you can use to do your installation. So for example, let's say I wanted to install a program that allows me to see my directory structure better in everything in one go, almost like a tree structure. There's an application called Tree, but it's not out of the box. If I say Tree, the command is not fine because the application is not installed. It's like you're trying to use Microsoft Word, but Word is not installed on your machine. So you need to install it first. So to do an installation on this platform Linux, you have to use YUM. So in this case, I want to install Tree. So I'm going to do, just bear with me now. I'm just going to do sudo. Don't worry about sudo for now. I say sudo yum install Tree. Okay, now go. Now, this machine, apart from the fact that the network is a bit slow here, this machine is not a top tier machine, so things are a bit slow on it because it's one CPU machine. So it's not going to be super responsive. So I say yes. It says, yeah, I found Tree. I want to install it. You want me to go ahead? I say yes, and then it goes. And now Tree is installed. If I now type Tree, it's there now. So let me clear the screen so you can appreciate tree a little bit. So tree just allows me to see my directory structure better. You can see now with tree, I can see things straight away in a more clearer fashion. I have a file here, I have a directory, I have another directory. This one has a subdirectory, this one has another directory. So you can see 4 directories in one file. And that's what tree gives you, right? You can go back one step. I'm in home. If I say tree, it should show me that I have EC2 user. Under EC2 user, I've got football, I've got masterclass, I've got week, I've got school. Right? And that's the beauty of tree. So you can see that Linux is almost like your Windows operating system, where you would create files, delete, we've not done any deletion of files, create folder, install an app, etc. So the last thing we're gonna do today is we're gonna play with our post deployment. Okay, and I'm gonna kind of create a scenario for that in a little bit. So if we go back here, so on this machine now, we've seen the CPU, we've seen the memory, we've created some files and directory, we're able to connect to it and play with it. Okay. One directive from the boss might be, okay, you've shown me the system has this memory, you show me the system has this CPU, you show me the system has this disk space. You might say, okay, that system looks good. So I want you to deploy our school software on that system. That could be a directory from the boss. Deploy the school software on the system. So maybe there's a school software program somewhere, which we don't know, which we're going to come to. The boss might say maybe for your task for this week will be to do that deployment on that Linux platform. Now you have a Linux platform you can play. We are very happy with it. It's good. It runs well. But you don't know how to do a deployment. You don't even have an idea what a deployment is. At least you know how to play with Linux machine. So the deployment is how you would turn a code into a working service or application on a machine. This machine is dead now, but it's utterly useless. It's not giving us anything. It is not providing any service to anyone, anywhere in the world right now. Okay. And usually machines are meant to do a task. This machine could be a machine that maybe keeps files, and then you call it a file server. This machine might be a machine that serves web pages, and then you call it a web server. This machine might be a machine that manages video or audio. You might call it an audio server. So depending on what the machine does, you then give it a name that kind of, suggests what it does, or email server, or what have you. What it serves is what you then potentially call it. One thing you need to bear in mind is one machine might be doing more than one thing. So your email server might still be your web server. It might still be your file server. What makes a machine do stuff is the application that is installed on it. Because this machine has tree now, okay, is able to actually view files and directory quite easily because it has a program that allows it to do it. What gives a machine a superpower is the application that is running on it. So this machine now is nothing now, rather than just a bland, useless machine. Okay, we can easily turn this machine, for example, now into a web server that's able to serve web pages. What would turn this ordinary machine to a web server is putting a web server or web service application on it. Okay. And then you might ask yourself, what is a web server or web service application? So this is obviously then comes to your experience. So there are a lot of applications that will turn an ordinary machine into a web server. The same way there are a lot of applications that when you install it on a machine, it will turn a machine into an email server. So what makes a machine an X server, whatever name you want to call it, is the software that is running on it. That is what gives it that superpower to be able to do that. So for example, this is going to be the last thing we're going to look at today. This machine, a humble Linux machine, we can turn this straight into a web server in just one go. But before we do that, what exactly is a web server? Okay. So a web server is a system that's able to serve web pages. So what do I mean by web pages? A web page is where you go on, is a page you're able to display via your browser. The World Wide Web. For example, I could do something like www.microsoft.com, and that would take me to the Microsoft web page. And I am the Microsoft web server is basically responding to my request here. Okay, the www.microsoft web server is responding to my request here. Because they have a web server running on at this end of the Microsoft platform. So likewise, you can, for example, say you are creating something like maybe the way about you want to do a property listing of housing. Maybe you're like a property tycoon that start building a property platform that people can go and check properties out. You might want to build a web server to show that property. Okay. So you then have a Linux machine that is bland, there's nothing on it. You can turn this straight into a web server. So let's see how we do that. Okay. Let's say the end goal here is to turn this machine into a web server that's able to show web content. In this case, maybe a property listing content. How do we do that? And this is where we're going to wrap things up. I wanted to cover this so you have enough to play with for the week. Okay, so the tool we're going to use that will turn this machine to a website is something we call Nginx. So there are 3 key or 4 key things we need to do. Okay. As far as web goes, anything that is web-based, for people to use it, they have to come through a browser to be able to use a web content. But for people that are actually building that web content, they will not build it. They would so people that are sort of deploying the web content, they will not deploy it essentially just by using the web page to deploy. By the way, when it comes to web content, bear in mind that the creator of a web content will probably be a developer or HTML content creator or whatever. Those will build the web content. So from a DevOps standpoint, you are not technically creating that content, but you're actually making that content. You are deploying it on a machine to make it available. The people that will build the content probably will be developers or HTML guys, a front-end guy who then, they do their magic. They make the files available to you, and then you put the file in the right place on the machine, and then you have the right software that's able to manipulate and make those web content available. So there's division of labor here. There are some people that actually create those content. They made those content available to the DevOps guy, and the DevOps guy will have to provision a platform, as well as making sure that the content are in the right place and the right software is there to make the web content work as it should be. So to get the web content, to turn a humble machine into a web server, the key software you need to install, a number of them, but the one we're going to look at today is Nginx. Nginx is a popular web server application that enables you to manage web content that will turn an ordinary machine into a web server. As soon as I install Nginx on this machine, it is no longer just a Linux machine. It becomes a web server. So how do I do that? This is the same yum command. Remember, I'll say sudo yum install Nginx. And then off I go. And then it says yes, and I say yes, and then off it goes. Now, Nginx is installed. I need to start it to make sure it's running. So I will say, before I start it, normally, so Nginx is installed on this machine, doesn't mean it's running. And I can always check that it's running or it's not running by doing what we call a check to the service. I will do something like curl. I will say localhost. I'm going to explain this in a bit. So what I'm trying to do is I'm trying to connect to the web server endpoint on this machine just to test. Obviously, I've installed Nginx. I want to test, can I connect to the Nginx service on here, it's failed because I know I've installed, but I've not started it. As soon as I started a do call, it would work. So this is a way to quickly test if your connectivity to your web server is working. Okay, so we've installed it, but we've not started it. So we're going to start it by using sudo service nginx start. And then now it's running. So if we then do this call thing again, now you see the code is responding and it's responsive. Okay, so now this machine is no longer just a Linux machine, it's become a web server. So that means potentially you should be able to come out, connect to the machine as an ordinary user and hit the machine and see what I see here or on your web page. Because now to access the web server as an end user, you would use the browser. Because we are the DevOps guy, that's why we are doing all these nice little things on the back end. But for people that are going to use the system, they don't know about all these Nginx and what have you that we are doing. They just want to use the service and hit the web server. So it's a very humble, bland web server now. We're going to make people access it. How do we make people access it and use our box as a web server? So you go back to the machine, if you recall. This machine is the one we are playing with. I did say to you that the machine has, if you go back to this analogy, if you're coming through the web, if you want to connect to the machine, you have to use the public name of the machine or the public IP of the machine. Okay. And then because we are the privileged guys, we've come in through a back door, do what we have to do, and we have access to everything on the machine. For people that are going to come through the front door who want to use the service, for example, the web service that we have created, they have to come through another gate. We've been coming through the privileged gates, which gives access to every single room on the machine. The people here, they won't have access to the machine as it were, but they're able to use the web service that we create. They're going to be very restricted, so they have to come in through another gate. So that gate is what we call the HTTPS gate, and that will be via the browser. Okay, so typically they will have to get the name. So what's the name? The name of the machine is, where is it? That's the public IP address which you can use, or you can also use the name of the machine. Where is it? Okay, public name or public IP address. So a typical user who wants to use the web service, which is not a DevOps guy, just an ordinary user who wants to use the web service that we just started, will go to his browser, we'll put this there. We will have to say HTTP. Okay, and then it will hit this endpoint. It's not going to work, bear with me. But this is what they're going to do. And it will just wait and eventually hangs. Okay, so what are we trying to do? We are trying to create a path. Let's see. We're trying to create a path for the people here to use the web server we just created. Let's check this out. So this guy wants to use a service that we just deploy on this machine. This machine is running Nginx, and they should be able to see something on the web browser that says hello Nginx, blah, 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 blah. But now that would fail. Where is it? Yeah, it's still pumping, sort of still trying. I'm going to share that on the chat here. You can try as well, because you are like an end user as well. So on the chat here, I am sharing that. It won't work, but just try first. And that will be you here. I've just shared that. That will be you here coming from outside trying to access the system, running Nginx, which has turned this humble Linux machine into a web server. Okay, right? It said now it's finally giving up. It said fail to open, blah, 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 blah. It's not because the service is not running. Okay, so the service is running. How do we know it's running? Because when we try locally on the machine, when you're on the machine, it's responding. Okay, so when we go on the machine here and we try our little thing, we're able to access that web Nginx system. We know it's working. But people coming from outside, an ordinary user who wants to use the Nginx service is not able to use it. The reason is because this gate is currently shut. Okay. When you're coming from over the browser as a user, you're coming by HTTP endpoint, okay, which is what I shared. The HTTP endpoint, which is that one. That gate currently is not open for security reasons. So you as a custodian of the machine, you can then decide to open that port, which is the gate. That gate, because every gate will be this called, we call the HTTP port. HTTP port is a port through which anyone using the browser who wants to access this machine, who wants to access this service. You can't access the machine. You want to access the web server or the web service of the system. You have to come in through the HTTP port. Okay, that is via your browser. Okay, that HTTP port currently is shut. As soon as we open that gate, then you'll be able to access the web server. So what do I mean? So this machine, okay, we're using the public name, we're giving you the public name through which you should access the machine, but yet you're not able to connect. There's some security as setup that is preventing you from doing that. So you go to security. Under security, you click on the security group, which is this one. So under security group, you'd say edit inbound. So under inbound, this is where you control the gates. So if we go back here again, this is what determines who is able to connect from a gate. So currently this is gate 22, which is by default how we will come in, but don't worry about that. Currently gate 22 is enabled, but don't worry about that. That is sort of by default. Gate 22. The gate we are interested in is not there, which is the HTTP gate. So if you say add rule and you go look for HTTP, you see HTTP there, you enable it, and you say, I want to enable it for everyone. This means for everyone. Because you can restrict it to who you enable it to as well. But it's HTTP for everyone. Going by the diagram again, this is HTTP port, but you want to make anyone across the world to be able to come in through this port. But that only limits them to the HTTP service. They will not be able to create file, they won't be able to create directory, they will only be able to use the web service. They will be able to use their browser to browse the content that we're providing to them. So when we enable that, so obviously an interview question will be that how do you make a port globally? And you say you will use 0.0.0/0, which means anyone across the web, across the world will be able to access that service. Remember, there are many gates. In this case, we are only specifying a gate, HTTP gate. That means that you can only do one thing. This HTTP gate only restricts you to HTTP service on the machine. You cannot create folder, you cannot delete files, you cannot list. You are only restricted to using the web service endpoint, web server endpoint, essentially. So you say save rule. That just opens this gate now because of what we did. If we then go back here again, as an ordinary user, you can try as well. Should be able to then access it. You can see now this works now. So we've turned this Umbo machine into a web server now. Okay, so it now becomes a web server. So if you try from your end, then you will see that you are now able to access it. So what I'm going to do next, don't worry about it, is I won't want you to worry. I just want you to see, because you probably don't appreciate what is happening now. But what you have now is a very powerful system that can do a lot of things. For example, this is just saying welcome to Nginx. You could have changed this to something else. But what I'm going to do is just for demonstration purpose. Don't worry if you don't know what I'm doing now. I just want to show you how powerful this could be. So don't worry about what I'm going to do for now, and don't worry to kind of understand it. For now, it doesn't really matter. But just for demonstration purpose, I could then go to and do whatever I'm doing now. Please don't worry about it. Sudo minus I. Just want to show you how this could be easily turned to a very powerful system. USR and share and Nginx, I suppose. HTML index HTML. Again, don't worry about what I'm doing right now. So I could then come here and say, we'll change this and say, welcome to template. Fact, I could change a whole lot of things here. Let me see if I could just do a few little beautiful things. All this will become clear to you by week 3, week 4. So what I'm doing now, don't worry about it. I just want to kind of demonstrate that. Linux. Okay, and then let's just why let's make it a lot. No. Okay, nice. Yeah. Just bear with me. Let me just do this real quick. Um, Linux, and then let's change this. Let's do YY, and let's do P. Let's just flood it. P. And then let's say, let's change out Nginx. Nginx. Nginx to TechBlitz. TechBlitz. There we go. Right. Okay. So I'm just kind of playing with this, and let's save it. And then off we go. So I've just done some simple manipulation. Don't worry about what I'm doing now. Just refresh this. You can see it's changed. So this is how you would build a portal. This is how you would build a website. And we're going to look at this, you know, in a much more bigger scale at some point. Again, what I'm doing now, don't worry about it. This could easily turn to something bigger. And that's what we're going to look at in the next classes, how you would, and then obviously because the web page, you can then add pictures, and then it becomes a proper portal. You can see now that your humble system is now becoming, it's become a web server, and then you can obviously add pictures, add stuff and whatever. So I just wanted to kind of establish the basics first. We're not going to dwell too much on Linux, but we're going to move fast and we're going to move to using cloud services. But it's important to understand the basics of systems, but we're not going to do on Linux too much. We're going to move fast to the cloud platform, etc. But it's important to kind of understand the basics, and because this is what we're going to build on going forward. So the last thing I want to do before we go is to clean up after yourself. So when you do all those things, because when you use the platform, because you're going to be using free tier, any machine you leave running will begin to count against you in terms of the time is, the amount of resources being used. I think they cap it at 200 points or something like that. So the more the longer you have the machine running, the more it's going to count against you. So when you finish and you wrap up whatever you do, always try to clean up and delete the machine. So in this case, I'll go to this machine. I'll say, running. So before I do that, actually, let me copy the commands I use. So what I did just now, don't worry about it. So let's stick to what we've done earlier. Yeah, so just gonna copy these ones out. And I'm gonna share this on Slack for us to see after class. I'm putting on Slack straight away now. So you should see it in Slack straight away now. So you can kind of use that as reference point. Okay, so I'm gonna try and delete the machine right now. So I'll select the machine. I will go to action. Instance state, and I will say terminate. And I will say terminate so I don't need shut down. I'm just going to say terminate, and I'll say terminate, and then we just destroy the machine. This is good because it then means all those things not counting against you. There's some things that are left behind, such as security group. Those are not important. But just make sure you delete the machine. That is very important, and that's what you have. So thank you, everyone. Before I kind of finish, this will be the last class for people that haven't yet made aligned their payment. I will not let them log in from next week. Let's bear that in mind. I wanted to kind of show you what we're going to be getting into. So I thought it makes sense to kind of, make it, accessible this weekend, but from next weekend, it will not be accessible. Also, I'm going to send the first task out by tomorrow. It's going to be easy. It's going to be most of what we've done in class today. Just kind of get your hands dirty and to get into that spirit of doing a task every week. Yeah, this is what it looks like. Please watch the videos. Things will ramp up as we kind of go ahead. I'm trying to take it super easy. Yeah, I hope it's not been too boring or too technical. So yeah, thank you everyone. Any questions or comments before we wrap up? Excellent. For people that have some sort of background experience, your task might be different to newbies. So yeah, so you might see two tasks for this week. So for people that are starting, for people that have a bit of experience, and it's only something to people that are starting to have a go as well. So it's not something that will be too hard to do. But I wouldn't expect you, because you just started to be attacking task B. So there will be task A for newbie and task B for people that are a bit more experienced. So thank you, everyone. Have a blessed week. I will share the video as soon as it's ready. Cheers.
Thank you. Please, sir, when is it likely we get the video, sir?
The video, it doesn't take time. Did you get the first one?
Yes, I got it and I've reviewed it. just to go
Okay,
again
so
with this
yeah,
one.
yeah. You can subscribe to the channel. So when you subscribe to the channel, as soon as it's loaded, it will pop up. But nonetheless, I will share the link on the platform anyway. But if you subscribe to my channel, the TechBit channel, as soon as it's pop up, you should get notified. But in another maybe 30 minutes, 1 hour, it should be there. Thank you.
Thank you, sir.